Geometry, we're doing the last of section of chapter 11 today. It's on applying measurements. And really what they're going to talk about here is the concept of density. And I think we've talked about this in science by this point. But if you remember, the definition I gave you in science is that density is mass divided by volume. You see, there has to be some way, like we can talk about weight. Um, well, there's an old riddle, okay? Which weighs more, a pound of feathers or a pound of lead? And of course, if you think about that for a moment, if they both weigh a pound, then they weigh the same. But what that question is really getting at, the reason why it's confusing to people, is because a pound of lead would be very compact and a pound of feathers would be very spread out. And so oftentimes people would say a pound of feathers weighs more, but what they really are wanting to talk about is density here. Density is a measure of how compact something is. Think about it. Mass is how many atoms there are in something, and volume is how much space it takes up. So if I could magically take this pen and break it down into little atoms and spread them apart, it's going to be the same amount of mass, but the volume is getting bigger. So if it was 1 to 1 before, now maybe it's 1 to 2 or 1 to 3 or 1 to 4. So do you see what's happening is the density is getting less. The more volume you have, the less dense something is, the more spread out it is. And I think we talked about this in science when we talked about things floating. Archimedes' principle says that things float if they have if they're less dense than water is. And water we consider to have a density of 1. It's 1 gram, I think it's per cubic centimeter. Yeah, that's what it is. So if something is less than 1, it will float. If it's more than 1, it won't. Which is why you can have these huge ocean liners that if you weighed them, they would weigh millions of pounds of steel and furniture and the motor and all that kind of stuff. But you put it into a shape that is very spread out, taking up a huge amount of volume. Those ocean liners are like cities or a house at least. And so when you take that amount of weight, that mass, and you spread it out like that, you can make it float. Of course, if you took it and you compressed it and you got rid of the volume, it would just sink like a rock. So that's the concept for this section. Now, why is this in the math book here? I think it's because we've been talking about volume and they wanted to throw in this. But truthfully, it's kind of a little bit of a weird thing to have here at the very end. So you can have questions since we've been talking about volume. What if they had a cube? Is that how you draw a cube? You get the idea. Something like that. I don't know. And so this is a cube, and they say that the sides of the cube are 3 centimeters. Every side is 3 centimeters. And they say that the mass of this cube is, let's say, 54 grams. And then they would ask you to figure out the density, let's say. Well, they give you one of them. They give you mass. So all we need to figure out, of course, is the volume. And since with your geometrical knowledge by this point, this should be a simple problem. It's length times width times height, and they're all 3. So 3 cubed is going to be 27. So get rid of this. It's going to be 27. And this would be cubic centimeters. So you can see that the density is going to be 2 grams per cubic centimeter, or whatever label it's in. But so that's a very simple problem there. They start off the section by talking about population density, which is a very similar topic. Think about it. Density was the amount of stuff in a certain space. Population density, they give you a definition, is density. They say the number of objects, and I think it's per area. So for me, I start with this and I just think, okay, this is the main topic, but if I want to be, kind of apply it in a little different way, well, which of these things has to do with mass? Obviously, it's the number of objects. Mass is the number of atoms in a space. Volume has to do with area. It's the amount of space they take up, okay? So you can apply it here. And so then they might ask you, if you had a certain amount of people in a house a certain size or a city a certain size, then you can figure out the population density. But it's related that way, okay? All right, I hope this made sense. I am out of here.